Thank you very much, Armon. Those were a lot of exciting updates, a lot of great things, console going 1.0, a UI available for everyone in NOMAD, really, really exciting stuff. And so I hope what you see is that every product is growing and maturing faster than we've ever been able to do it before, and we're really excited to have been able to share with you some of these exciting new features. And so what we're seeing, really, is that the growth of infrastructure and applications has been really enabled in a big part by the ability to automate more effectively. Going on this undated timeline, back to configuration and code and the rise of virtual machines, those things enabled fast, automatic machine setup that we didn't have before. And then cloud providers, infrastructure as code, and tools such as TERRAFORM are enabling fast, automatic infrastructure creation that was difficult to achieve before. Trends like containers and microservices allow us to much more easily package our application runtimes and get them out there. And then schedulers have enabled automatic application placement, deployment, as well as operational tasks such as rolling deploys and so on that have allowed us to just deploy a much larger number of applications. And so automation has brought all these really amazing capabilities that were simply not really possible before. However, it's also brought a number of challenges. For example, in the age of VMs and manual procurement, if you place an order for 5,000 new machines, a human would probably call you and say, like, are you sure this is the correct order? Or if you tried to deploy an application that was requesting all the resources of your biggest machine, again, someone would probably stop you and say, like, is this what you truly meant to do? But today, with automation, these things could just happen, and they happen really, really fast. And so today, we want a way to enforce problems such as forbidding changing configuration outside of business hours. This is a pretty easy way to introduce instability, page people, have people work at times you don't really want them to be working. It's something you want to check. Or ensure all services have associated health checks. We want to make sure that every service we deploy can be monitored at least at some minimal level before it's actually running and serving user traffic. Or verifying that all the TLS certificates that we issue are encrypted with a key size of at least 2048 bits, just to ensure some minimum expectation of security. Or perhaps to ensure that all instances we launch in scenarios where we have multiple lines of business have a billing ID tagged with it so we know which organization is using this. And these are all problems that previously could have been easily solved with human verification, but today is very, very difficult in the age of automation. And so today, what I'm happy to announce is the availability of something we call Sentinel. It's a system and framework for policy as code. Sentinel is an enterprise-only feature that is being integrated into all our products. And to see how Sentinel solves some of these problems, let's take a look at those examples one more time. So each of these examples actually corresponds with a HashiCorp tool that's capable of automatically solving that problem in combination with Sentinel. And going through each one, if we take a look at the first one of Console Enterprise, we'd like to forbid changing configuration outside of working hours. And this is actually the associated Sentinel policy that would enforce that. We're going to cover language, syntax, some other things a little bit later in detail, but I hope what you could see here is that it's pretty easy to understand and see what it's doing, which is verifying that all keys that start with the service namespace can only be modified within the standard business hours of 8 a.m. and 5 p.m. And if we take a look next at NOMAD, we want to ensure all services have associated health checks. Equally easily, we're just looking at the job structure and verifying that all tasks that are within the job structure have at least one health check associated with it. Moving on next to Vault, where we'd like to maintain some base security by ensuring all TLS certificates are encrypted with at least a 2048-bit key. We could do this by making sure that when a PKI role is created, which is how you define who could create TLS certificates within Vault, that their minimum required bit size is always at least 2048. And then finally, with Terraform, ensuring all instances have a certain tag that we expect. This one, we could go over a plan that's been made and verify that any AWS instances in the plan contain a billing ID tag. These are 4 common problems that real customers have brought up to us over the years, and they all now share the same easy solution. And that solution is what we call Sentinel. And so those are the problems that Sentinel can solve. But what is it? How does it work? Let's take a look at that next. So Sentinel embraces this concept that we call policy as code. And what policy as code does is bring all the same benefits you know and love with infrastructure as code and bring them down to policy. And by representing policy as code, we're able to use proven software development practices with policies. And this is in contrast to other policy systems that use graphical user interfaces for updating or application-specific endpoints, because the problem with these is that they're very difficult and not easily repeatable, versionable, or most importantly, testable. And Sentinel solves all of these cases. And to do that, Sentinel is really 4 separate things. It's a language, it's an embedded framework, it's a workflow, and it's an ecosystem of imports. And so starting with the language, Sentinel does use its own policy language that was designed specifically to make writing policies easy. We designed it with hundreds of customer examples and translating those from English into the policy and trying to make that as easy and straightforward as possible. One of the things we found was that a lot of the people that are responsible for enforcing this policy within businesses do not have a strong programming background. You cannot throw at them a programming language because they're not comfortable doing that. But with something like Sentinel, where it almost becomes English and it's almost one-for-one, they were able to effectively write and enforce policy across multiple systems. It was also built to be safe in a highly security-sensitive environment such as Vault. Sentinel is integrated with Vault, and we can't compromise the security of Vault because of it. And so that was designed with that in mind. And then to run this language, Sentinel is an embedded framework. And embedded is a really important word, because what that means is that Sentinel itself is built into the applications. You don't run another application next to it. You don't have to deploy something new. And Sentinel is actively right in the data path of what's happening. And so what this lets you do is what we call active enforcement. Sentinel actually actively sees a behavior coming in before it takes effect and can perform policy checks on that behavior at that time and reject them if they fail. So you don't detect after a key's been written to console. You don't even allow that key to be written to console in the first place. The policies run right there. But while we do active enforcement, Sentinel is also capable of passive enforcement. So Sentinel can continuously run in the background and continuously check the state of your systems to ensure that they haven't been pushed into a policy-violating behavior by some external force. So for example, with Terraform, we could continuously run Sentinel against the Terraform state, and if someone goes into something like the AWS console and deletes a tag, we will detect that your system was pushed into a policy-violating behavior outside of the Terraform workflow. Sentinel also natively supports the concept of what we call enforcement levels. And the enforcement levels it supports we call advisory, soft mandatory, and hard mandatory. Enforcement levels are broad types of policies that we found existed across all of our customer advisors while building Sentinel. Advisory policies allow a policy to fail, but actively show a user a warning of what failed and why. These are useful for scenarios where you'd like to educate a user that they're perhaps doing something not quite right, or if you're deprecating something and you want to warn them that they shouldn't be using this version anymore. Soft mandatory policies require that the policy pass, but it could be overridden with the proper privileges. These privileges may be the same person, they may require another person. And these policies are super useful in cases such as don't allow deploys on Fridays. Deploys on Fridays, easy way to get people working late or over the weekend. Maybe that's not a good idea, but of course you have to deploy sometimes on a Friday. Things happen. So soft mandatory policies are a way to require an explicit override, an explicit acknowledgement that you're doing something that could be dangerous. And overrides always appear in logs so that you know when overrides happen, who initiated the override, and who initiated the original request as well. And then hard mandatory levels cannot be overridden and must pass under any circumstance short of actually removing that policy itself, which itself is a fairly privileged operation. And hard mandatory policies are really great for business requirements as well as legal compliance and assisting in making those a little bit more robust. And so we have the language and we have the embedded framework to actually run that language and enforce policy. And we think the Sentinel is a really great technology, but having a really great technology just isn't enough and doesn't solve the actual core problem that we're trying to solve. You also need to think about the development, test, and deployment workflows of these policies. We think those are just as important as actually building a powerful policy system. And so what we've done is build into Sentinel a powerful workflow. So Sentinel ships with a local CLI that we call the Sentinel simulator. The Sentinel simulator is a single binary with 0 dependencies, and it lets you write and test policies against any Sentinel-enabled system without access to that system, all locally on your own machine. The policies are developed in text files. We are pushing policy as code, so you code your policies in text files, and they could be run using a command called Sentinel apply. This command can mock any data that a system exposes to your policy so that you could develop that policy without that system. And when policies fail, you could also see the failure, but also the logic that led to that failure and the various rules that passed or failed that led to that result. In addition to simply developing policies, evaluating them locally, seeing if they pass, fail, we expect all our customers and users of Sentinel to eventually grow to hundreds, thousands of policies, and reasoning about those, ensuring they behave correctly, is extremely important and is a challenge today. So Sentinel also includes a full test runner and test framework within the Sentinel simulator that you can use to test your policies. And what this looks like here is you define an environment in which the policy is running. Again, you mock all the information that the system would give you. You don't have to run console. You don't have to run vault. It all just runs in memory. And what you do is you assert that the policy behaves as you expect. But you don't just assert that the policy passes or fails, because perhaps that policy is passing or failing for some completely unrelated reason from what you're testing. So you could also assert the various logical rules that led to that pass or fail so that you know it's passing or failing for the reason you expect. And this CLI was designed to run in continuous integration environments. So you could see no parameters. As long as you follow the right folder structure, we'll run thousands of policy tests automatically, all in memory. And we're encouraging everybody to run this in their CI environments to constantly have continuous testing of their policies. This also lets it work extremely well with version control, pull requests for policies, etc. You get all those benefits directly with Sentinel that you can't get when you're manually editing policies directly through a system. And so that is the powerful workflow Sentinel provides. And the last thing I want to talk about is the ecosystem of imports. Sentinel can use plugins that we call imports to source external information for use in policy decisions. And this is a really extremely powerful concept, especially once you think through the ramifications of this. Your policies aren't limited to only the information that the system is giving you to make that decision. You could query and get information from any external system you want in order to make your policy decisions. So as an example, we have a customer that uses Terraform that also uses ServiceNow that wants to ensure that their Terraform changes can't go into infrastructure until there's a change management request in ServiceNow that matches that change. And they could do this with Sentinel by writing a plugin. These plugins are exposed to Sentinel as imports, and imports expose functions and data you could use within Sentinel to make these decisions. And the Sentinel simulator can also mock all of this data. So you don't even need access to the plugins. You don't need to have access to a ServiceNow cluster if you're writing that plugin. You could mock all of it locally to still develop policies against this right on your own machine offline. And anybody could build a Sentinel plugin using the SDK, which is publicly available. The SDK provides a test framework to verify your plugins and gives you examples in order to build these things so that you could work with any external information source. And these plugins then work with any Sentinel-enabled application. So for example, if I wrote a plugin that sourced data from S3, the moment I build that plugin, I can now source data from S3 in console policies, NOMAD, Vault, Terraform, all of them without modifying that binary. The plugins use our production-ready plugin system we've developed for the past 5 years and build on top of it. And additionally, the plugins use the new gRPC mechanism in our plugin framework, so you could write plugins in any language. And those are the 4 aspects of Sentinel that make it a really incredible system for policy as code. And as I said earlier, Sentinel is integrated natively into all our enterprise tools. It's available in the next version of each, and it's ready to go. I'd like to show you what it looks like in each of those. So with Terraform Enterprise, you could define policies that run between a Terraform plan and a Terraform apply. And these policies have access to the entire Terraform configuration, the Terraform plan, the Terraform state, and a simulated version of the state after the apply. So you could use all of this information to determine if an apply is allowed to happen. And so this is the same example as previously, but you can see we're going over the plan to verify it has a tag. Equally, you could go over the plan to verify, for example, that no tags are being removed, that only tags could be added. You can't remove things. You could do just about anything with this. With Console and Console Enterprise, you're able to define policies that run during KV modify events, as well as service registration and updates. And so in these scenarios, you could enforce whether a KV modify is allowed to happen or a service registration is allowed to happen. And so in the example I have here, what we're doing is if the service name is prefixed with a user and a hyphen, we're enforcing that that must be deployed within a CIDR block that perhaps has higher levels of security or monitoring or something. We just require those services to live in that CIDR block, and we can enforce that right here. With Vault Enterprise, policies are split into 2 types of policies. We have what we call role governing policies, and we have what are called endpoint governing policies. Role governing policies are attached, as you might expect, to roles. So whenever you make an API request using a token that has that role, we execute that policy. Endpoint governing policies are attached to specific API endpoints, whether you're authenticated or unauthenticated, and whenever you hit that endpoint, we execute that policy. Both of these policies have access to the same amount of data, which is a lot. You have access to the full identity of the person requesting, you have the full request package, and a lot more. And so in this example, what we're actually doing is ensuring that people who log in with LDAP are only allowed to request read-only database credentials. You must log in with another mechanism in order to get write database credentials. And then with Nomad Enterprise, you're able to define policies that run before a new job is created or a job is updated. And these have access to the full job definition that's being sent. So what you could do with this, in this example, for example, is ensure that all tasks, all jobs that are deployed into the Nomad cluster are sourcing their artifacts from an internal Artifactory instance. They cannot source artifacts from an external source. And you can see sort of where you could go with this and the amount of power you actually are able to have. And one of the customers that we worked with in the design from the very beginning with Sentinel was Barclays, one of the world's largest financial firms. Barclays is planning on using Sentinel to provide safety guardrails for provisioning cloud resources. This will allow their expert operators to define reusable Terraform modules within the registry, best practices with Terraform, and give them out to over 15,000 users of operators within Terraform, and know that they're safely using Terraform across their entire organization. It's really great to see how Barclays is going to put Sentinel to use in their cloud, and we have to thank them for being really great customer advisors during the design of Sentinel. And so we're really excited about Sentinel, and you could learn about it today at HashiCorp.com/Sentinel.